This week in class, we're learning about Ethernet, and one of the labs allows you to examine the switches and how the switches learn MAC addresses and map them to their switch ports, which is called the MAC address table. So in this lab, I'm using the Netlab from NDG, which allows me to automate and use a web browser to interface with real switches and routers and PCs, but doing it remotely in an automated web browser interface. So I've got the lab here, and I've got two switches, S1 and S2, and two PCs. And you can see S1 is connected to S2 on switch port 1. And then PCA connects to S1 on S1's fast Ethernet 06 switch port, and PCB connects to S2 on the switch S2's fast Ethernet 18 switch port. So what we're going to do is we're going to kind of see how the switch learns about MAC addresses. So first of all, what we can do is we go to S1 here, and I've already been working on it a little bit. So first thing I'll do is show you that you can do a show interface F0/1, and it'll show me the information about the switch port, about the fast Ethernet switch port interface F0/1, or interface port 1. And you can see here it's up, the line protocol is up because it's connected to switch S2. And also right on the second line it says it's a fast Ethernet and its address is, and this is the MAC address or burned in address. And you can see the last four characters here in hex characters are A681. So that is the MAC address. Okay, so what I can do now is say, does S2 know about S1's MAC address? So if I go over here to S2, and one thing I can do is at first I'll clear the MAC address table. Let me just clear it. Clear MAC address table dynamic, sounds good. And then I'll run a show MAC address dash table. Also, to get to this mode, first of all, if I exit, you can see here, first thing you do is you hit enter and then type enable, you get to privileged exec mode, and I'll put show MAC address dash table, and I'll hit the space bar, and down here you can see on port 1 it's learned about A681. Now this is the MAC address for S1. So S2 learns that the MAC address for this switch port is connected to F0/1, and it records it in its MAC address table. So it learns about S1. It also probably learned about PCA. Let's take a look here again. So there's another one, FB48. It also is registered to port 1. So it might have also learned that PCA, when it talks to PCB, or when PCA communicates and it goes across the network, S2 sees the source MAC address from PCA, and it says, okay, I learned that there's a device out there with that MAC address, and it registers and says to reach it, it's located on port 0/1. So in other words, S2 says, if you want to reach this device's MAC address, I'm going to forward it out of port 1 because that's where I've seen this MAC address. So S2 is learning those things. Now let's see if I run that show MAC address table command again, if it learns about anything else yet. And so far, nope, just these two MAC addresses. Now let's verify that PCA has that MAC address. As you can see, PCA does not have right now an IP address. It has an APIPA 169.254 IP address. But let's take a look at its MAC address. So I'll do an ipconfig /all command, and I'll scroll back up, and there is the MAC address, the physical address of the Ethernet adapter local area connection, and you can see FB48. So sure enough, S2 learned about PCA. Now what I'm going to do is I'm going to give PCA an IP address. So I'll right click here, open the network and internet settings, and I'll scroll down, change adapter options, and I'm going to give it an IP address. So I'll say properties. I'm going to statically configure an IP address on this PC. So we'll go here and say 192.168.1.1 and the subnet mask, and no gateway because there's no router in this exercise, just 2 PCs and 2 switches, so an IP address and a subnet mask is fine. So we'll close that. Make sure you close it. And now I'll close this. I want to see if that registered. So I'll put in the command ipconfig/all again and just double check that it registered the address. And there it is. So it has the IP address and there's that MAC address, FB48. All right, perfect. So I'm gonna now, what I'll do is, once again, our topology here, PCA is 1.1 and PCB is 192.168.1.2. So I will similarly, it doesn't have an IP address yet, it just has an APIPA, automatic private IP addressing. So, and I had released the IP address, so I need to set that too. So let's go do that really quickly. And we'll scroll down. And let's see here. Network and Sharing Center, that's fine. I'll just go to the Network and Sharing Center this time, change adapter settings. There we go. And properties, and scroll down to IPv4, Internet Protocol version 4, and give it the IP address, 192.168.1.2. So PCA is 1.1, and this device is 1.2, and then the default subnet mask 255.255.255.0. Okay, and then you have to close it out. Okay, I'll close out all these windows and verify that I have the address set. All right, perfect, I do. So now what I can do is I can ping the other host on the network. So I'll ping 192.168.1.1. As long as the firewalls are down on the hosts, we should get a reply. And we do have a reply here. So there is 4 echo requests and 4 echo replies, or 4 pings and then 4 return pongs. And so I've gotten reply here. Now we can look at S2 and look at that MAC address table again and see if it's learned any new MAC addresses. So we put in the command show MAC address dash table, and we go through here all the way down, and you can see here port 18, right? That's S1. I'm sorry, port 18. It learned about port 18 8244 and port 18 FB for 5111. So it now sees 2 MAC addresses registered with port 18. Now, before we just had, well, port 1 showed S1 and port 1 showed PCA, but now we have port 18, we've got some MAC address information. So if we look at the topology here, S2 connects to PCB on port 18. Now, this is Netlab, which is an automated system, and I can tell you that these 2 PCs are actually virtual machines that are being served from a VMware server. So that VMware server connects to a control switch, which is in between S2 and S1. So in other words, S2 actually connects to a hidden switch, which is in between PCB and S2. And S1 connects to that hidden same switch, which is in between S1 and PCA, between the VMware servers serving these virtual machines. So that's probably why I see 2 MAC addresses associated with port 18. So that's no mystery. Now let's look at PCB's MAC address and see which one is it. So you can see here that the physical address, I'm on PCB here, and it's 4F50. And on S2 here, or it looked like 4F50. Yeah, physical, oh, nope, that's the NP cap. That's not the right interface. That's the loop back adapter. So that was incorrect. So what we'll do is we'll do an ipconfig all, and we'll look up here, and we'll see, okay, there's the local area connection Ethernet adapter, and it's 5111. So now if I go to S2, I say, okay, 5111 on port 18, that's PCB. So that's great. Okay, so it can actually see those things. Now, also, not only does the switches have mappings between MAC addresses that it learns from the source MAC address as frames travel across the network, and the switches map these MAC addresses to these switch ports, but also the PCs learn MAC addresses as well. So if I go to PCB, and once again, PCB had, if PCB had pinged 1.1, if you remember, 192.168.1.1, and it successfully pinged it. If we want to see what MAC addresses the PC knows about, we look at the ARP cache. And so if I look at an ARP-A or ARP/A, and we can see the ARP cache, and we can see that host 1.1 has this MAC address right here. And then we see some other MAC addresses related to a broadcast MAC address, and this is a multicast MAC address, and this is another broadcast MAC address. But associated with an actual device, we can see that 192.168.1.1 PCA has this MAC address, FB48. And before it had this address, it had this APIPA address, 169.254.4480. Notice the same MAC address, right? Because we changed the IP address from the automatic private IP addressing and statically configured it with 1.1. So the other thing that we can do is we can give, we could see the process of learning these MAC addresses by running Wireshark and maybe emptying this cache. So we could actually see that process. So I could run Wireshark here. Let's just see if we can do it really quickly. All right, I'm going to run Wireshark. Okay, I can see activity on the local area connection right here. So I will start a capture. And then from my command prompt, I'll delete my ARP cache. So ARP/D to delete. It requires elevation. All right, so I need admin privileges. So I'll right click, or I'll say start CMD, and then I'll launch that command prompt as an administrator. Now I have admin privileges, and I can delete my ARP cache. I'll delete it once, I'll delete it twice. Then I'll ping host 192.168.1.1, and I'm getting the replies. So now if I look in Wireshark, I'll just stretch this down. I'll stop my capture here. You can see there is my ARP broadcast, and you can see that for me, a VMware, it's a virtual machine PCB. This is the PCB MAC address 51.11, and I send out a broadcast, and it's an ARP broadcast saying who has the MAC address for 192.168.1.1. Tell me 1.2. And then you see there's the reply, and the reply is FB48. That's the MAC address for host 1.1. So this broadcast was sent out across the network, and it went past S2, it went past S1 and reached PCA, and then I got a reply eventually. And if we take a look at this broadcast, you can see there's the broadcast MAC address, all Fs. All right, and that's pretty interesting. So this ARP broadcast happened before the pings, which are the ICMPs right here. The other thing that you can do in this lab that's really important is also give IP addresses to these switches, and that's important. So right now the switches by default are layer 2 switches. They don't need IP addresses unless you're going to manage them remotely using SSH or using Telnet and using a remote management. Right now I have a console connection in the switch, which doesn't require the switch to have an IP address. But let's give the switch an IP address anyway and then practice pinging it. So what I'll do is I'll go to global config mode, and I'll go interface VLAN 1. So we put the IP address on the switch on the switched virtual interface. And since all of the switch ports right now are in VLAN 1, we're going to associate the IP address of this switch with VLAN 1. So we put it on a virtual interface called interface VLAN 1. So here goes. IP add 192.168.1.11, which is what they want you to do in the instructions, in the lab document. And then I have to turn it on with a no shutdown command. Basically, I have to enable that interface. So there goes an IP address for S1. Now I'll do the same thing for S2. I'll go to global config mode and say interface VLAN 1, the switched virtual interface, and I'll give it the IP address 192.168.1.12, and then the subnet mask, and then no shut. So now we should have an IP address on both of these switches. Now let's see if that worked out. What I'll do is I'll do a Control C and then show IP interface brief. And we can see here under the show IP interface brief command that the VLAN 1 interface has this IP address, and it's physically up, means it's enabled with the no shutdown command, and the protocol's up, meaning we have a cable plugged into a switch port in VLAN 1. And all of the switch ports by default on the switch are in VLAN 1 to begin with. Notice Fast Ethernet 6 is up and up because that's connected to PCA. None of the other switch ports are up because it only has this one device connected, which is PCA on port 6. And then, of course, port 1 is up and up because port 1 connects over to S2. And if we look at S2 and do the same command, show IP interface brief, we should see VLAN 1, which we do. We should see port 1, which is connected to S1, and we should see port 18, which connects to PCB, and we do. So that's pretty good. Okay, so now from PCB, if I wanted to, I could, let's say, delete my ARP cache again, ARP/D, and delete that cache, and delete it again, and then maybe I'll start a capture here. Continue without saving, start a new capture, and then maybe I'll ping the switch. So ping 1.11. We'll see here. That should ping S1. Now notice there's some ARP resolutions happening needing to resolve the MAC address. I got to find the MAC address of 1.11 before I can ping it. And then I'll ping 1.12. Notice it's hesitating because it doesn't know the MAC address of 1.12. Okay, now I learned the MAC address for 1.12. And then let's take a look here. What do I know as a PC? ARP/all. Well, I know now that host 11 has this MAC address, so I can deliver a frame here. I know that 1.12 S2 has this MAC address, so I can deliver a frame there. But I don't see host 1.1. I don't know the MAC address for PCA. So if I want to talk to PCA at 192.168.1.1 and send him a ping, an echo request, I'll have to resolve the MAC address first before I deliver the frame. And now, if we look here, ARP/all, now you can see I know the MAC address for 1.1, 1.11, and 1.12, and I had to learn this first before I can deliver anything, because it's delivered in an Ethernet network. Packets are frames, Ethernet frames are delivered to MAC addresses on an Ethernet network. That's how Ethernet works. Okay, so now let's stop that capture here. I can stop that capture. And if I want to, I can take a look at all those ARP requests by just filtering, using a display filter for ARP. And now we can see all of the ARP requests. So here's ARP broadcasts. Who has 1.11? Who has 1.12? Who has 1.1? And then basically that gets flooded because it gets broadcasted throughout the network. And then only one device is going to reply back. The device that is 1.1 will reply back with their MAC address, which you can see. So in the reply here, who has 1.1, tell 1.2. 1.1 is at FB48, and you can see here that's coming from source FB48. Meanwhile, the switches are building their MAC address tables. So if we look at S1, you'll be able to see those MAC address tables. Let's see here. Show MAC address-table, and we go through here, and you can see that it's learned about these MAC addresses.